Swayam Prabha. Digital India. Educated India.
Welcome to today's lecture. This is lecture number 27 under module 7. This means fluidics and fluid logic, and the lecture is on basic devices, symbols and circuits. In a fluidic device, a jet of fluid can be deflected by a weaker jet striking it at the side. This means that fluidic device, as already I have told, that there is no moving components except the fluid is moving inside. So, imagine a fluid is flowing in a direction and that is being disturbed by another flow from the transverse directions or direction at an angle. This provides nonlinear amplification. It is similar to transistor used in electronic digital logic. It is used mostly in environments where electronic digital logic would be unreliable, that is, systems exposed to high levels of electromagnetic interference, ionizing radiations, etc. In the field of nanotechnology, fluidics is considered as one of its instruments. I would say, in other words, the word nanotechnology is used for various fields. In case of medical science involved with fluid flowing, nowadays the fluidics is finding its way that it can be utilized in better ways than any other devices. In this domain, effects such as fluid solid and fluid fluid interface forces are often highly significant. Fluidics devices have also been used for military applications. Some devices are described in brief in this lecture. Now, basic concept of fluid amplifier is described through a patented device as shown in this figure. Now, if you look into this figure, that from the bottom something is flowing through this body. This is basically, you can imagine a cavity between two plates, two bodies, there is a cavity inside. Now, what is there? There is a main flow, it is flowing like this. Now, there are at this zone there are two inputs. You should call this is input, this is some disturbing jets. Now, it is like that when C1 is being actuated, then flow is moving like this. when C2 is being actuated, the flow is going like this, and it is going through the D2, and it is going in case of C1 it will go via D1. If we consider the pressure in these directions, usually these devices are of low pressure, even if for the main flow, and the disturbing flow is even of much less pressure, but it is the fluid mechanics in which with this disturbance, basically which are normally laminar flow will be disturbed and it will move in a particular directions. For that, what we need, that we need to have some pressure range in these two flow as well as shape of this body. A fluid supply which may be air, the fluid may be air, water or hydraulic fluid. I have described that is entering at the bottom, and then pressure applied through this control port C1 and C2 to have the flow in D1 and D2 directions. The stream entering the control ports may be much weaker, which I have described, than the stream being deflected. So, the device has gain. This means that we normally by the small force we are deflecting a relatively larger force, and that we are getting output through this larger force. So, therefore, we should call it gain in terms of the gain used in both electrical fluid and any control field. Now, with this basic device, the flip flops and other fluidic logic elements also can be constructed. Basic principles remain same. Simple systems of digital logic can thus be built. This means we have already learned about the digital logic. Now, with this we can make the device which are called gates, different type of gates, and with these gates we can build the logic, and we can construct also physical circuits. However, fluidic amplifiers typically have bandwidths in the low kilohertz range. So, system built from them are quite slow compared to electronic devices. That we have to remember, the response will be slow in this case. However, say for example, in many medical instruments these fluidic devices are used where it is not required like a computer calculations, but we require much accuracy, safety and hazard free operations. Now, basic device, when first it was developed, then basic was the triode, this amplifier, and then the fluidic triode is an amplification device, and that used a fluid to convey the signal. Now, if we look into this history, then the fluidic triodes were used as the final stage in the main public address system in the year 1964 New York World's Fair. The name of the fair is 1964 New York World's Fair. Now, surprisingly, this fluid triode was invented just 2 years earlier to this fair by a boy who is Mari Medici Junior. He was a high school student, but he invented this fluidic triode. Obviously, it is not electronic device, it was some this rather you can say mechanical part along with the fluid parts, and he built a fluid diode, a fluid oscillator and a variety of hydraulic circuits, including one that has no electronic counterpart. As yet there is no electron. That means, with fluidics we can make many devices, and which may not be available with electronic. On the other hand, there are many things in electronic also which cannot be achieved by fluidics. Now, he was invited in this National Science Fair, and he was also awarded for his project. Now, although much studied in laboratory then onwards have been done, but there are really few practical applications, because to make a particularly to make a circuit, although these fluidic devices are very small, may not be very big, but in comparison to electronics components it is big. However, at the time when the fluidics was developed, the fluidic components were developed, that time there was not much progress in electronic devices. So, fluidic devices were initially was being used for automation and other control system. However, those were not very quiet. We had to many such devices, when they are connected together, the shape was very large, etc. And so, it was in many cases it was found that it may not be feasible to use such devices for making a control circuit or logical circuit. Many accept them to be key elements of nanotechnology. Now, nowadays it is found that which didn't find its application in general industrial applications or other devices, but it is expected that those will be used in nanotechnology. Now, this is a very simple system is shown. Imagine a pocket like this. It has 3 holes, which is like tube, and at the middle position there is a bucket. Let us consider it is in the vertical positions. You can imagine that a plate is machined like this, 2 plates are machined like this, and they are put together in reverse way. That means, the other plate is the mirror image of this, and that is put together. So, this means that this is one passage, this is another passage, this is a cavity inside, this is another passage to go out, and there is some sort of bucket is placed there. Now, what we can do, let us we can put a ball of diameter is very close to the diameter of the tube, not very small, neither it is very tight. So, one ball you can it can come through this passage, another ball can come through this passage. Now, forget about the probability, what may happen, these 2 balls will fall in this bucket, or it will fall outside, and then through this passage only one ball can go. Now, if suppose you have sent only one ball, so this will go out, then there will be some function will be performed, that one output is there, or this ball has come through this, then the performance will be there, or if the 2 ball come through this and one by one it is coming out, still the performance will be there. If nothing is coming out, no performance here. On the other hand, if these 2 balls, instead of coming over here, they take this bucket, or that means these 2 balls fall inside this bucket, then there will be another functions. Now, this is just to understand, when these 2 together coming, then one function, and if any one of them coming through this, then another function is being performed. So, this is basically to understand what is OR function and what is AND function. This is described what I have already told you. Now, logic gates can be built that use water instead of electricity to power the gating function. This means, in this case the function itself is performed by the fluid flow. This indicates that you may need to amplify this power. In case of electrical devices, the power is directly taken from the electrical source. That means, whatever is being used for the control, that can be magnified, that can be amplified, and can be used for the power. In this case also we can magnify those, but we have to use the source as a water or other fluid, say air. These are reliant on being positioned in the orientation to perform correctly. This means that you have to make sure that the orientations are correct, and you have to construct the devices accordingly. In case of electrical devices, you can say electric flow is through and where, you can put in any directions, but in case of a fluidic device, you have to careful about this path, except where the flexible path can be used, flexible tube can be used, say for example. An OR gate is simply two pipes being merged. A NOT gate consists of A deflecting a supply stream to produce A bar. Now, here instead of going into much detail definition of these gates, there is a NOT function. NOT function is simply, remember, because there will be a NOR function also. Now, NOT function is that simply one function we are reversing, that inverse of that function. Suppose A in OR function A means 1, through some input there is a signal, output is 1. Now, if you would like to make it not 1, then simply you disturb that, not allow to go through that. That means, what was going to be output as a 1, you are diverting that. Then we call inverse of that, not of that. This means, we are this output could be A. Now, by applying a disturbance, we are getting the output A bar, not A, that is designated by A bar. So, it is called NOT gate. An inverter could also be implemented with the OR gate. This is XOR, XOR, as A or 1 is equal to A bar. Okay. The fluidic components appear in some hydraulic and pneumatic systems, including some automotive for automatic transmissions. This is just an information. As digital logic has become more accepted in industrial control, the role of fluidics in industrial control has declined. That means, digital logic means electronics logic nowadays available. So, you may not find much applications of fluidics in industrial control. Fluidic injection is being researched for thrust vectoring in aircraft jet engine nozzles and for ships. So, only the fluidic principle is being used for fluid injection in case of engines, jet engines, mainly ships and aircraft. and this is because of that their function is more efficient for less consumption of the fluid less consumption of the fuel and to increase the efficiency. Such systems divert thrust via fluid effects. That means, again as I should mention that we are diverting a thrust by simply weak and disturbance fluids which is of much less pressure. Tests show that air forced into a jet engine exhaust stream can deflect thrust up to 15 degrees. So, this is just an information. So, a small jet of very low pressure can divert a thrust into 15 degrees. This means that the thrust is coming, if you can divert that, that will have better impact on the impeller, which will give more power output. Such nozzles are desirable for their lower mass cost, up to 50% less inertia for faster, stronger control response, complexity, mechanically simpler, no moving parts or surfaces, and radar cross sections and stealth. Now, this is also used in unmanned aerial vehicles, that is UAVs, and also advanced fighter aircraft. Now, we shall discuss about a device. Now, in this device, this is a pneumatic device, also the similar fluid device or hydraulic device can be made, but the this describes precisely a logic gates. Now, look at this. This is the input. Input means, as I told, a flow that not very high pressure, this flow is there. Now, this flow is going through this and then going out in normal conditions when the lever at this position. So, if this flow is there, then there is a flow output. So, what we put input 1, output A is also 1. Now, this is being used to perform some performance. So, it is going to the next device. Now, here I would say that in this case the fluidic devices, as I told, that it should be have laminar flow even if for the mainstream. In this case this disturbance not by the jet, but this disturbance is, or we can call it second input, that we are moving this lever. While we are moving this lever, then this is being closed, this fluid is going out, that is it is going out to exhaust. If we consider the output here, then it is reverse of the output here. So, it is A bar, which is equal to 0, it is not A. This means that by operating this on off etc., we are getting that at either the flow is going to next device or the flow is going to exhaust. So, device is not being operated. So, this is called this is basically used in to use as a float, say for example, water level control in a tank, etc. Now, the similar function can be achieved by a fluidic amplifier device also. How? Now, in this case, Let us consider this is a large tube and it is blocked here. A small piece of large tube, large diameter tube, it is blocked here. Now, what it is having? Imagine this is a cylindrical body, this may be square also, rectangular body or square cross section body, but let us imagine this is a circular one. Now, here there is a small hole. Okay. Now, in that small hole again a nozzle type small pipe is inserted, through which again one flow can enter into this. Now, in this case there is no physical connection between this hole to this hole, simply there is a hole, and in this side it may be a tube like this or may not be tube, but the flow we can consider that supply of this is air, P is the pressure and A is the air, not P air. Now, this flow is a laminar flow. It is like that if this flow is allowed through this hole, straightway it will go here. You can imagine that as if it is going through a tube, it is like that. Now, when this flow is initiated, that means this flow is given, then it will be disturbed and it will go through another larger hole, it will go out and it will not, this flow will not come in this way. So, it will not go to next device and the work will not be performed. So, this is a basically a hydraulic device, this is not a logic device, not fluidic device, because here is the moving part. In that case there is no moving part except the fluid is moving, and the function is same. Now, if you look into this pressure, here 34 millibar, you can imagine that 34 millibar, 1 bar is equal to 0.1 megapascal, and millibar means you can imagine this is divided by 10 to the power 3, 34 millibar only, and whereas this disturbance is 1 millibar minimum. Of course, it can be slightly higher, but you need at least 1 millibar, and when this disturbance is on this fluid, you can see that it is being bent at 12 millibar, this pressure is not there. Now, as I told this, if you would like to use this air source to drive something, say for example, in that case it needs amplification. Say suppose we need say at least say 340 millibar, say that means we have to amplify 10 times, that is different issue, but 340 millibar air we cannot pass through this to have this performance. This is usually low pressure. Now, for low pressure pneumatic logic application, a tubular laminar or turbulence device is a well known fluidic element working on jet interaction principle. This is basically a knot or NOR device. It consists of a short tube with two concentric smaller tubes, which I have described, and this flow is laminar. Now, we can have one or more disturbing jet. That means, in that case, say for example, this work, I mean this will be disturbed, either one input or maybe either of the one of the all the disturbance z are there, or maybe 3 z at a time. So, this means that this is say in a systems, it is like that if one disturbance is there, this will not be performed. If 2-3 disturbance at a time also there will be no performance. Only this will be performed, it will go to the next device, there is no disturbance. So, we can make this device multiple input and single output. So, this is again I have shown this, and the symbol for multiple input, it is like that. This symbol is used for this device. Symbolically, it shows that any of the control inputs A, B, C or D can turn the output U of the device to 0 when A or B or C or D is, or when all of them are equal to 1. This thing I think here we can put 1. This means that A, B, C, D, any of them is 1 or all of them 1. Okay. So long they are all 0 and output U is equal to 1 is available. That means, only then if they are 0, only then there will be this Z will go to the next device and the performance will be achieved. So, this is basically a NOR device. The combination of a shuttle valve and a 3-port spool valve may also act as an inverter. This I will show. That is, it can generate NOR logic functions. How? Now, what we have used? We have used a shuttle valve here, and then we have used another 3-port spool valve. The inputs A and B, this is A and this is B, there are 2 inputs connected to the 2 shuttle valves, or in other words say you can call that this is a shuttle valve, 2 ends of the shuttle valve, so that A is equal to 1, B is stopped, and when B is equal to 1, A is stopped. That means, when the flow is coming through this, it can go this direction, this will be stopped, or when the flow is coming from B, A will be stopped and flow is going in the directions. That means, either A or B, this will be operated. Okay. If the flow from both sides is coming, this will be operated also, because this ball will be in the intermediate position, but there will be passage to go here. So, this is basically OR function. So, either A or B can work in an exclusive way without interfering each other. However, the same effect is produced when both A 1 and B is equal to 1. The 3-port valve gets a control input, and this moves it against the spring, and the output from this valve is then 0. This means that if you look into this valve, what is there? This indicates, looking into this symbol, this indicates that there is an input flow and it is going out. Okay. But when there is an actuation, then this will come to this position and the flow will be stopped. So, if these are present, then there is no function, no output. Function means no output. So, that means that either A or B or both of them reverse of that. If A is there, no output. If B is there, no output. If A and B both are there, no output. So, symbolically, sorry, this in equation form we would write like this: A is equal to A or B, this is plus or B, and inverse of that A plus B bar. Okay. So, this at this point I would like to tell you that actually to remember all such things we need a practice, because we are habituated with normal algebra, general algebra, and this is following Boolean algebra, and say suppose if it would follow the general algebra, in that case we could have remembered easily, but as you see this function is something different, we need a practice. Only when A is equal to 0 and B is equal to 0 and output is obtained from this valve, hence it is a NOR logic systems. The conceptual logic gates like AND or NOT, and or not, etc., can be fabricated as hardware, electrical, electronic or fluid operated, and when these hardware are suitably interconnected and interfaced, many problems of automation can be tackled easily. These arrangements are termed as circuits. If such devices are put in sequence with a proper connection between them and we achieve a desired performance, then we call it circuit and we call is logic circuit. Now, let us see the logic gates and their symbols. Now, this symbol is like this, it is like a D, capital D, and look at this symbol carefully. One simple line is coming this side from left to right, and then this is the line with an arrow, this we should consider as output, whereas this is input. Now, what it is doing, meaning a ES gate or amplification gate. Now, they are a little confusing, that ES means a flow is coming in and that flow is going out. Now, why we should call it amplifications? May not be it is amplified, the same input is going out, even there might have some loss also, pressure drop also, but why we should call amplification gate? Amplification gate we call it whenever this is not being disturbed and going out, we should call this is amplifications. Now, here we find that the same D, but there is a vertical bar. In that case, A is input and then this will be output is reverse of A. Okay. That means, if A is 1, say let us consider in that case 1 and 0. Suppose if you consider 1 means there is a flow and 0 means there is no flow, then suddenly the inverse of no flow must be flow is there. So, it is normally not possible, we cannot think of, we have not given at flow at all, how it can come the output, but usually this device is like that, there will be flow. If there is this flow is not being passed through this only, then this is not A. think in this way, because we are not discussing the internal details of this. Okay. Now, next one, so it is called inverse gate, and in this case the first one has no alternative symbol is used, but mostly you will find in electrical circuit this type of symbols are used. This is called bubbled, a bubble is used. So, it is not, but we can also, because this is basically we will call logic circuit. Say for example, we would like to achieve some performance. In that case, what we should do? We should first make the logic circuits, then we will think of whether we should go for fluidic device or electronic device. So, you may find also in fluidic device also this type of circuit sometimes are being used. Now, next you look at this, here input is 2, double input, and then output is A plus B. This plus means or A or B. That means, if there is a signal at A, then the output is there. If there is signal at B, then there is a output. Both A and B are there, there will be output, but if A is not there, B is not there, then only this will be 0, no signal. So, this represents OR gate, or we call it logic sum gate. It has also an alternative symbol which is like this. Okay. Usually with these signs there is no arrow is used, and remember usually with all these symbols, this A, B, A plus B etcetera are written. That means, if you do not write this A, B, A plus B, then maybe in some cases it might be difficult to understand what is the actual device is, because in many cases they look alike. Not many cases, in some cases I would say look alike. Say in this case you see these two look alike, but this is for A dot B, that means meaning AND gate. What is AND gate? Suppose A is there, B is not there, then this is like in general algebra. In that case, this output will be 0. If B is there, A is not there, then is also output is 0. Only if A and B both are there, then there will be output. So, there is the distinct difference between this and this. This is OR gate, this is AND gate, this is logic sum, this is logic product, and in this case you will find that alternative symbol has difference. This device and this device has difference. So, even if these are not written, still you can understand, but in this case you have to write to understand this device. And also observe here D, and this also looks like capital D, but there is a difference. This is this half circle plus straight line, where this is normally semicircle or even less. Some of the logic gates are combined and are given new names, which indicate the functional base of combinations. That means, we have seen OR gate, AND gate, NOT gate etcetera. NOR gate also is there. Now, combining OR and NOT, we can make a NOR gate. We are coming to that. Now, here some are shown. Now, let us see these symbols. This is OR, we have used the alternative symbol here. OR gate, and there is a NOT gate. Combining this, we are getting NOR gate. Now, NOR gate is while we are presenting the NOR gate, we have taken this part and we have taken this bubble. The intermediate portion is eliminated. This means that OR and NOT, NOR gate. But remember, in this device, first performance will be OR and then NOT of OR. Do not be confused. It is not like that you can put in other sequence to get NOT device. You have to put in this sequence. Physically, you can put OR device and NOT device and get a NOR, and but the NOR device also can be made separately, as we have seen earlier. Now, this is also represented as like this. Okay. Usually with these symbols, you will find A B, A plus B bar is given. Okay. Take another one. In this case, we have put AND and NOT. Now, this is called NAND, but this is not very popular one, NAND. The same way, and alternative one is this. If you look into these two are again only device looks alike, only symbol looks alike, but the when we put A plus B bar or A dot B bar, that indicates the two different device. This is NOR, this is NAND. Okay. So, these are combining the symbols. Now, another interesting part is that by De Morgan's theorem, what we have learned earlier, it follows that if inputs are passed first through NOT gates, remember first we are sending through NOT gates in input, and then through an OR gate, the final output is the same as putting the inputs first through AND gate and then output inverted by NOT gate. Look at this. Earlier I told that if we put NOT and OR, we will not get NOR. To get a NOR, OR and then NOT. But if you put NOT and then OR, what actually you will get? You will get first AND and then NOT. This means that you may think of NAND. You are getting NOT OR is equal to NAND. So, this using De Morgan theorems we have already learned, and symbolically NAND is equal to bubbled OR. Say this output we have written here NAND, and this can be given bubbled OR. What it is? Input and NOT, this input and NOT, and then output is OR. This is your OR connections. So, we get bubbled OR. You look at these symbols, and this is one De Morgan theorem, and also if you take NOR, then NOT AND, what we do the reverse way, NOT AND then OR. So, we get NOR, sorry, NOT and we get NOR. Okay. Just remember this, if you put OR and NOT, you will get NOR, NOT for both inputs and OR you will get NAND, and vice versa. Positive and negative logic gave rise to basic duality in all identities. When changing from one logic system to another, 0 becomes 1 and vice versa. So, these are termed as duality. So, just saying these line sentence you may not have feeling at the immediately, but if you read it, if you learn it, you will have this feeling. All the plus sign are changed to dot sign, or AND gates becomes OR gates, and vice versa. From this it is called duality. For example, A plus 0 is equal to A has the dual identity A dot 1 is equal to A. Similarly, A plus A bar is equal to 1 has its dual as A dot A bar is equal to 0. As it has been mentioned already, simplification enables an equivalent simpler circuit to be built in place of more complicated one. We have learned about simplification earlier. Now, here something also will be shown. For instance, if a logic output is given by y is equal to A dot C plus A dot B dot C, that means A and C, then A and B and C, which means an output is available when A and C or A and B and C, the input condition are satisfied. The expression can be simplified by Boolean method as follows. Now, you see this how we are simplifying this. Y is equal to, simply you can, while you are simplifying, you just remember this thing. Then writing this equation, you may omit this dot, AC plus ABC, simply write it AC plus ABC, no harm. Then this you can take the like an ordinary algebra, you can take AC common. So, this becomes 1 plus B. Okay. Now, 1 plus B is a OR in Boolean algebra, and then as there is 1, that means always there is a positive output. Then B, whatever it may be, whether it is 0 or 1, it will be always 1. So, this means that this simplification is Boolean algebra, you can make simplify to AC. Okay. Similarly, another expression, if we consider y is equal to A bar dot B bar dot C bar dot C bar plus A dot B C bar plus A bar dot B bar dot C, that also can be simplified in this form. How? You take A bar C bar common here, then in that case you will find that B bar plus B is coming over there, plus here A bar B bar C. Now, this is again, this is always, suppose this is 1, this is 1, then this is 0, and if this is 0, then this is 1, that means this part is always 1. So, this become A bar C bar, and this becomes A bar B bar C bar, and that is equal to again A bar C bar B bar C, and finally, we get only A bar, then C bar B bar C, B bar, because if suppose C is equal to 1, then C bar will be 0, and whatever the B bar, that will be the value there. And similarly, if you analyze this one, these two will give the same result. Okay. So, this again, as I told you, it is not easy to grasp immediately, you need a practice. You have to just 2-3 times you have to see this, how this simplification is done. Another example is that x dot y plus A dot B dot C dot into x y plus A bar plus B bar plus C bar. Okay. Now, this First you follow the ordinary algebra. As I told that you can write x y plus a b c and x y plus a bar plus b bar plus c bar, does not matter, but remember these three items are separate items, a b c not a single item, there are three items. Remembering this, you can write down these equations, then you will arrive into this, and finally you will find this one. That means these functions, these are, you can see so many inputs, 1 2 3 4 5 inputs are there, and their not functions are there, that can be simply achieved by x y 2 inputs and a AND function. So, this is becoming x y. Now, this can be proved by this logic circuit. I shall discuss this logic circuits later, and this can be simply represented by this one. Okay. So, I think we shall continue in the next lecture this one. Similarly, if we take another example, that we will have also the same, that first we simplify this, u a plus b into a plus c is simply can be represented by a plus b c. That means, put an input a, and then for b c there is a AND gate, and then finally you pass through a OR gate. Okay. And this circuit, as you see, that this circuit can be simplified as follows. In that case, you see a b, say if you had to make this function full function in a circuit, this will be the circuit. Okay. A plus b through an OR gate, c through an OR gate, and a also the same OR gate. So, we are getting this output, then these two are this AND gate. Instead of that, use a OR gate here, directly put a there, b and c through AND gate, and then you are getting the output. So, these three devices simplified into two devices, one is not required. So, such simplification is required in logic circuits arrived into a simplest circuit. So, we shall discuss in next lecture.